For years, the story we've been told about AI has been pretty simple. Bigger is always better. But what if that's not the whole picture? What if AI's most annoying flaws aren't just little bugs we can squash, but are actually fundamental laws we can never, ever break? All right, let's get into it. I mean, really, the entire story of modern AI is just this relentless drive for more. More data, more compute, and models with a number of parameters that is, well, it's just gotten insane. If you go back just to 2018, OpenAI's GPT-1 was the talk of the town. It had 117 million parameters, and at the time, that seemed massive. That was the state of the art. And today, GPT-4 is estimated to have over 1 trillion parameters. That's not just a step up. That's 1,000 times bigger in just a handful of years. It is an absolutely mind-boggling jump. So with all that incredible power, you'd think we'd be getting pretty close to perfection, right? But we're not. Instead, we're seeing these massive models fail in weird, persistent, and sometimes even more frustrating ways than the smaller ones. And this is the central paradox we're diving into. This quote from the source material just says it all. As these things get smarter, their mistakes get, well, they get more confident, more convincing, and honestly, that makes them potentially more dangerous. So, this brings us right to the main event. Are these failures temporary bugs that we can just engineer our way out of, or are they permanent features, something literally baked into the math of how AI works? For the longest time, the industry playbook was super simple. If the model hallucinates or makes a reasoning mistake, you just throw more at it. More data, more parameters, more power. The solution to every problem was just scale it up. And this really shows the two different ways of thinking. On the left, you've got the classic engineering mindset, right? Any problem can be fixed if you just have a big enough wrench. But on the right, that's a much more radical idea, that these aren't just tech glitches, they're problems of pure logic. And this is the core idea we're exploring, the theory that no matter how gigantic we build these models, they will always have certain unbreakable limits. Not because of bad engineering, but because the laws of mathematics guarantee it. So let's start with the one you've probably heard about the most, hallucination. When an AI just confidently makes stuff up. It's the perfect way to see these abstract math ideas play out in the real world. And let's be super clear on what we mean here. A hallucination isn't just getting something wrong. It's when the model gives you an answer that sounds completely plausible, totally fluent and confident, but it's just flat out false. So why does this keep happening? Well, the research points to 3 deep mathematical reasons that make hallucinations pretty much unavoidable for any AI we can actually build. Let's walk through them. Okay, the first one is a bit of a mind bender. It's a logical paradox called diagonalization. Think of it this way. Imagine trying to write a book that lists all the books in the world that don't mention themselves. The very second you finish writing it, your book is wrong because it doesn't mention itself. It's a logical trap. The same logic means that for any AI, you can always create a question that it is mathematically guaranteed to fail. There's no escape. Second, some questions are just unanswerable. The most famous one is called the halting problem. Basically, can you write a computer program that can look at any other program and tell you if it will ever finish running or just get stuck in a loop forever? The legendary Alan Turing proved it's impossible. So when you ask an AI an impossible question, it has only 2 choices. It can say, I don't know, or it can guess. And if its job is to always give an answer, it's going to guess. And eventually, it's going to hallucinate. And the third reason? Honestly, this one is the most intuitive of them all. An AI model, no matter how huge, is a finite thing. It exists on a computer. But the number of facts and ideas and relationships in the universe is, for all practical purposes, infinite. So, you see the problem, right? It's fundamentally about information. It's like trying to pack an infinite wardrobe into a finite suitcase. It doesn't matter how big you make the suitcase. 1 trillion parameters, 100 trillion, you're still trying to stuff infinity inside. You're going to have to fold things, wrinkle them, maybe leave a few things out. In AI, those wrinkles, that lost information, that's what a hallucination is. So, we've gone deep on hallucination, but believe me, it is not the only limit. The research points to 4 other fundamental walls that just building bigger models isn't going to solve. Yeah, this diagram really shows you the whole iceberg. We've just been talking about that one piece, hallucination. but it's actually part of this bigger, interconnected system of 5 fundamental challenges. So let's quickly run through the other 4. So what else is on the list? First, there's context compression. Ever been in a long chat with an AI and you get the feeling it forgot what you said 10 minutes ago? That's this. Next is reasoning degradation. This is where the AI is brilliant at mimicking patterns it's seen, but it falls apart when it has to do real, from scratch logical reasoning. Then you have retrieval fragility. This is when the AI tries to look up a fact to ground its answer, but it gets confused or distracted, kind of like a web search gone horribly wrong. And finally, multimodal misalignment. This is a new one. When you start mixing text, images, and audio all together, you don't just add cool new features, you create entirely new and exciting ways for the AI to get confused. Okay, so if all these limits are real and unbreakable, does that mean we're stuck? Is this the end of the road for AI progress? No, not at all. It just means we have to start thinking about progress in a whole new way. The path forward probably isn't this endless race to build bigger and bigger models, hoping one day we can just brute force our way through the laws of mathematics. I mean, that's like trying to build a rocket that's so powerful it can break the law of gravity. It's just not how physics works. Instead, the future is about being smarter, not just bigger. It's about designing systems that are aware of these limits, systems that respect them. It's about working with these boundaries, not fighting against them. Think of things like better fact-checking tools built right in, or using smaller, specialized models that are really good at one thing. And this quote from the paper just hits the nail on the head. We need to stop thinking of this as some unbounded engineering problem and start seeing it for what it is, a scientific process that has real fundamental constraints. And that really leaves us with this final big question. For so long, it felt like the goal was to build some kind of perfect, all-knowing God-like AI. But maybe the real goal is something else. Maybe it's about building a smarter mirror. A mirror that can reflect all of human knowledge back at us. Powerful, brilliant, and incredibly useful, but also reflecting the beautiful and, yes, unbreakable flaws that are inherent in any system that tries to make sense of an infinite world.